Hello students, today I will begin with the most important, which is multiple choice questions for your paper classical mechanics. So as you are appearing for the examination for the first time in this pattern MCQ, right? In TYBSC also you appeared it, right? So I think same logic will be applied, which means the examination will be only for 1 hour, even though time slot given is 2 hours. Time for which you will be appearing is only for 1 hour, 60 minutes, in which you will have to solve almost 50 questions. 60 questions will be given to you and 50 correct will be counted. So you need to be little quick. So don't feel that it's a 2-hour exam, it's only for a 1-hour examination. Okay. So I'll try my level best to complete at least 30 questions. Today I might cover only 5-6. Let's see how much we need time. So the first question over here I will be considering in how much time will the plane of oscillation of a Foucault's pendulum turn through 90 degrees and 30 degrees latitude, right? So this is our third module, in which you do observe that the options are A, B, C, D, correct? So if you know the theory well, you won't need time to just click what is the correct options. So theory behind this is what? That the period of one rotation of plane of oscillation of Foucault's pendulum is given. This is the derivation which we did, is T is equal to 24 hours by sine phi. And if the plane of oscillation be rotating with an angular velocity theta, that's why I said usually we write T is equal to 2 pi by omega. So here, as I said, angular velocity is theta, so I wrote over here 2 pi by theta. Now my job is to compare this and this. So here I can say T is equal to, this is nothing but 360 divided by theta. And if at all I compare these two equations, that 360 by theta is equal to 24 hours by sine phi, right? What I get, I can multiply over here and say 24 hours into theta is equal to 360 into sine phi. Fine. So therefore I can say theta is equal to 360 divided by 24 into sine phi. So if at all you do the conversion, so you get exactly 24 ones are 24, and remaining you get 8, so exactly you have 15 degrees sine phi. This is what you have done in theory, right? So now the question is, we need to check that it has to turn through 90 degrees and 30 degrees latitude, means you have been given phi, right? So you can see as phi, which is latitude, in this case is 30 degrees, how much is my sine phi will be there? Sine phi will be sine 30, and sine 30 is 1 by 2 or half. So then what will be your question? You have to turn through 90 degrees, right? So simple logic we'll have to use, which is theta is equal to 15 degrees sine phi, because theta is 15 degrees sine phi. So how much I got the answer for sine phi, which is half. So it should become 7.5 degrees. So I am almost close to the answer. Now I need to just check how many hours will be required for the plane of oscillation of Foucault's pendulum to turn through 90. So here the simple question will be, for to turn through 90 degrees, to turn through 90 degrees, what I have to do? I have to do 7.5 degrees into how much hours I have to get to 90 degrees, right? So if at all I say this is x hours, so this implies x hours is equal to 90 degrees by 7.5, right? So if at all I do so, I will get what is called as 12 hours exactly, right? So therefore To turn to 90 degrees, I am going to need exactly 12 hours in case of Foucault's pendulum. This is the way we can solve the problem. So once you know this formula, theta is 15 degrees sine phi. Your job is to put the value of latitude, which is 30 degrees. Sine phi is 30, so half. So 15 into half is 7.5. So per hour 7.5. So 7.5 into 12 will get you through 90 degrees exactly. This is the way we will be solving the problems over here. Right? We'll move towards the second question now. Question number 2. A rocket is moving upward with acceleration 3g. Calculate the effective weight of a man sitting in it if his actual weight is 75 kg. Right? The rocket is obviously going upwards. The person sitting in the rocket whose weight is 75 kg. So the formula is over here. The total force Fn is Fi, the real force or the true force, plus Fo, which is a fictitious force or a pseudo force. So the formula for Fi or the true force is minus m into Gn. Fine. So over here, the weight of the person we said is 75. So minus 75 Gn is my equation. And the value of fictitious force will be minus m into A0. How much is A0? It is 3Gn because it's given with acceleration. It's moving upward with 3G. So minus 75 into 3Gn will give me minus 225 Gn. Right. Now after getting these two answers, equation number 3 and 4, my job is to put the value over here. So I can see Fn is equal to Fi, which is minus 75 Gn. And this Fo is minus 225 Gn will give me minus 300 Gn, right? So after getting minus 300 Gn, or I can say in short, or we can say it's 300 kg, right? Now we'll say that what about the minus sign, right? As per the formula, the answer will be minus 300 Gn, but when you have to say that the rocket is moving upward, correct? So the weight will be definitely downward, like we are seeing in the case of the lift. If lift is either going up or down, correct? We are seeing the formulas accordingly. So over here, in this case, I'll have to choose the option. So exactly minus 75 and minus 225 is going to give me the answer 300 kg. So correct answer will be A, which is 300 kg over here. Okay. Then we'll move to question number 3. Question number 3. The generating function F2 generates which transformation? So we are seeing in the module number 2 that you have total 4 functions. One is F1, F2, F3 and F4. Right? All these functions usually have P. Along with that, you have one old and one new coordinate. So here you have suppose Qi, correct? Then second should be capital Qi. In F2 you say you keep Qi but you change it to Pi. Third will be Pi, Qi, and the last will be Pi and Pi. This T is there. So even though you do not use it over here, not a big deal, right? So you say that function F2 is basically Qi into Pi summation over I. And what are the equations over here? The equations in case of F2 is given by small pi is equal to summation F2 by Qi, right? Second equation is capital Qi is equal to dabba F2 by dabba Pi. Substitute the value of F2 over here. So I say dabba by dabba Qi of Qi Pi. Fine. Here also dabba by dabba Pi Qi Pi. Right. So when you differentiate this is dabba by dabba Qi of Qi into Pi. So definitely the answer will be capital Pi. And in this case, the answer should be small qi because dabba pi by dabba pi will be 1. So qi is constant, so which is out. Here also pi. So what do you say? Pi is equal to pi and qi is equal to qi. So small pi is equal to capital Pi and capital Qi is equal to small qi, which means F2 generates the identity transformation. Okay, we are moved from the old set to new set. So here we have the old set coordinate momentum is equal to new set of coordinate momentum. Here also the new set of generalized coordinate to the old set of generalized coordinate. This is the way we can solve the simple question over here. Now we move to the question number 4. Question number 4. The generating function for capital Q to be 1 by P, small p, and capital P is QP square transformation is. So our job is now to find here the generating function. So what is the formula to find the generating function, or to find first is it exact or not? Is small p dq minus capital P dq. Now over here you have been given capital Q, so I have to go for this. So my next job is to find out dq. So what is the formula to get dq? dq will be dava q by dava q dq plus dava q by dava p dp, equation number 2. Now find out this value, which is dava q by dava q should be, how much is q? 1 upon p. What is the answer? 0. Next should be dava q by dava p. What is the value of q? 1 by p. So what is the answer here? Minus 1 upon p square. Right? So if you put the value over here, what is my equation number 2 become? Equation number 2 become dq is equal to, this term is 0, so minus 1 upon p square dp, equation number 3. Right? Next job is multiply it by p. So I can say, therefore p dq is equal to, p is how much? qp square multiplied by minus 1 upon p square. So if you cancel this, we get the answer to be minus qd. Perfect. Now call equation number 1. So I can say equation number 1, df is equal to p dq minus capital P dq, whose value is minus q dp. So over here I can write p dq plus q dp. This is my equation number 4. Now after getting this, my job is to find generating function. Right? So over here, what we need to do? We need to simply get what is called as generating function df is equal to dava by dava q of the function dq plus dava by dava p of the function d. Right? Now I have to choose which function I have to use by which I get this answer. Right? So if at all I choose capital PQ, correct, I won't be able to differentiate this, obviously. But if at all I put this function, correct, what will I get the answer here? PQ, and here also PQ. Now in this case, dava by dava q of q is 1, so I'll have to write PDQ. So here I'll get PDQ, here I'll get dava by dava P of P, Q will be QDP. Right? That's what I'm expecting. Right? So therefore, the correct answer is this. But if at all you try any other options, option number 1, 3, A, C or D, you will not get this equation, which means the perfect answer will be small pq, which means generating function for the given transformation turned out to be small p into q. Right? Now we'll move towards the question number 5. The next question, question number 5, is very basics. What we do in TYBSC also, or even in MSc, for the first chapter, the first module, the degrees of freedom for a system of n particles constrained by m equations will be. So everybody knows what are the constraints. Okay, constraints are the restriction for the motion of the particle. So if at all you have a system consisting of n number of particles, right? You usually use the word that 3n is the number of generalized coordinates will be required. And if at all you have m equations which are the constants, then you obviously say that 3n minus m will be my degrees of freedom of n particle constrained by m equation, will be given by basically 3n minus m. Correct? So now we have finished total 5 questions. See how you understand it. Okay. Today I will stop over here, but next lecture, depending on the response, I will move forward with at least 10 more questions daily. Correct? So that's what is my plan. So only one request is, see to it that you share with your friends, even let them get benefited, because till now I have not seen any other MCQs on classical mechanics on any YouTube video. Okay, so see to it that you share it, by which others also will be benefited from it. Thank you very much.